Okay, so today is a little review of what we're going to see on Monday for the test. So it's nice, so when we do this review, hang on to this, okay? Put this in your notebook so you can use this on Monday. It should be a lot of help, okay? So number one, draw opposite rays. Now opposite rays are just two rays that go opposite directions. So, but it's got to be on plane P. So I'm going to draw a plane. Remember how we drew a plane? Kind of like that. We'll make P. So I'll start there, right? Plane P. I kind of try and make it look like a parallelogram because it's a perspective, so I'm looking down at it. That's why I make it look like a parallelogram. Now if it's rays A, B, and BC, they have a common point B, don't they? They both have B. So when I draw opposite rays, I'll do my B and my A here. Does that make sense? I've got AB, but it's B is the end point, and then BC has to go the direct opposite way. Okay, there's opposite rays. There are two rays. It looks like a line. In fact, it makes a line, doesn't it? Opposite rays do make a line. But you've got ray BA and ray BC, which makes the opposite rays, okay? Easy. Okay, number two, find the length of AC, all right? This looks a lot like what we did in our warm-up today. So what we're going to do is, we know this piece plus this piece equals a whole thing, so I'll do the work up here. I'll take my 2x plus 8 plus my 5x minus 6 equals the whole length, which is my 8x minus 4. How am I doing? Thumbs up? Add the pieces together. 7x, let's see, an 8 plus a negative 6 makes a 2 equals my 8x minus 4, right? I've got x's on both sides, so let's get rid of the 7x. I'm going to go minus 7x minus 7x. So I'll have a 2 equals an x minus 4. 1x and x are the same thing. I could put a 1 there if I wanted to. I don't really need to, but just solving. Plus 4 plus 4. So I get x equals 6. But that's not the answer, right? We need to find AC. AC is this 8x minus 4. So let me take my 6 and put it right there. All right? So the length of AC is going to be 8 times 6 minus 4. 48 minus 4 should be 44. So AC is going to be 44. Can you do this on Monday? Thumbs up? Probably not.
It's right here for us.
There it is. There it is. The numbers might be different. Same type of problem, okay? All right. So now, first of all, before I do and measure, I know this angle's got to be bigger than 90. Everybody agree? So when you use your protractor, you're going to see two numbers. You are. But make sure you use the number that's bigger than 90. Let's just use a little common sense. So if I put my protractor down, put the vertex on the center. Put the vertex of the angle on the center. Zero it out. And I see two numbers. Okay, extend a little bit. I see either a 55, can't be, or a 125, which it is, right? So you want to take the number that's certainly going to be bigger. If I go 0, 10, 20, 30, 40, all the way over to about 125 degrees. The name is, it's an obtuse angle, right? It's obtuse. It's greater than 90, it's obtuse. All right. Number 3 is probably 90. You guys agree? 90. I'm going to put a box right there. 90, which makes it a right angle. Yep. Okay, number 3. Okay, when I look at this, again, it's going to be less than 90, but agree? It's going to be an acute angle. When I use my protractor, again, I'm going to see two different numbers on my protractor, right? One's going to be the obtuse angle, which it's not, and the other angle is going to be the acute angle. So if I put my protractor down, zero it out, I see either about a 29 or 30 degree angle or 150. Well, it can't be 150, right? It's way too small. So 30, I might say 28 if I wanted to get at, well, pretty close to 30. Maybe I'll say 30 degrees. How's that? Right? So when you see the two numbers, use a little common sense. That angle obviously can't be 150. Don't use the bigger number, use the small number, okay? Thumbs up? Easy, good, all right. All right, number 4, keyword. We're going to get really used to keywords because we're going to be doing a lot of geometry in here that takes words that mean something. Bisects. That's a keyword. So if it bisects, then it cuts it in half, right? And if it cuts it in half, you get two equal parts. So I know that this angle RTV is equal to angle VTS. I know they're equal because it bisects. So let's set them equal. 7x plus 2 equals a 4 times a 2x minus 1, right? How am I doing, Nate? You copying this down? Good man. Okay. So I set the two angles equal because of the word bisects. Let me distribute. I'm going to get an 8x minus 4, 7x plus 2, right? Minus 7x minus 7x. How about 2 equals a 1x minus 4. X equals 6, right? Okay, but that's not the answer. We want RTS. Let's see, RTS. Now RTS is the big angle. So what I'm going to do is I'm going to put the 6 into one of these two angles and just double it. Okay, I'm going to put the 6, take the 6, let's put it right into here. Okay, so I'll go 7 times 6 plus 2. 42 plus 2 is 44, but that's not my answer either because I need the whole angle. I need the whole thing. So I know this is 44, 44 and 44, so the whole thing's got to be 88 degrees. Thumbs up. Sideways. Okay, not too bad. If it says bisects, just means they're equal, right? Set them equal and solve, all right? Okay, name each angle pair. Now, here's the thing. There are definitely, you could call a lot of these adjacent or whatever. Let's use the most specific name we can. I'll help you out with that, okay? For instance, check out angle 5 and 4, okay? Or 2 and 4. We could call these all adjacent. I don't want that. I'm adjacent, yes, but let's be more specific, okay? So let's go back to angle 1 and 2. Angle 1 and 2. There's nothing special about them. They're not complementary, 1 and 2. They're not a linear pair. They're not vertical angles. They're just plain old adjacent. Okay. 5 and 2. They're opposite, right? Those are called vertical. See the V? Those are called vertical angles. Six and 5. Yes, they're adjacent, but I don't want that answer because there's something better. 6 and 5 add up to 90, right? So they're complementary. Four and 5, yes, they're adjacent, but they're something more than that, so don't put down adjacent. 4 and 5 are either going to be a linear pair or supplementary. Either one. I like the linear pair better, but linear pair. If you put supplementary, I wouldn't count that wrong. That's pretty specific as well, okay? So when we look at these, please give me the most specific one you can give me. All right, turn the page. All right, carry it. So, 6, find the area and perimeter. Garrett's going to tell you always do your homework, right, Garrett?
Oh, yes.
You agree?
Yes.
Yes. Okay, find the area. So first of all, the area is pretty easy. The area of this one is just going to be length times width, which is going to be an x plus 3 times an x. And that's an okay answer. I would take that answer. A better answer would be x squared plus 3x. That's a better answer, but I'd take either one of those, okay? So if you're not really good at multiplying things out, you know, x plus 3 times x is still base times height, right? Perimeter, let's see, that's an x plus 3, that's an x. Sully, I liked how you used your formula. Nice job. I'm just going to add them up. You guys okay with that? Your formula is great. I'm going to go x, 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 4x, right? Perimeter, 4x, 3 and 3 makes 6. How's that? I like the way you did it, by the way. Your way was nicer. More mathematical. Okay, everybody good on that? So we can't get an answer. The answer is going to be in terms of x. Same thing with the circle. Our answer is going to be in terms of x. So let's take a look first of all at area. Area of a circle is pi r squared. So is going to be pi times 3x squared, okay? Now, that answer's fine as well, but you need the parentheses. You have to have the parentheses because you need to square the 3 and the x, correct? You need the parentheses because you need the 3x squared. Now, another answer for that could be a 9x squared pi. I like that answer best, but you know, that's a better answer. Circumference, because there's really, when you talk about perimeter of a circle, you're not really talking about perimeter, you're talking about circumference of a circle, which is 2 pi r, right? So my circumference is going to be 2 pi times 3x, because that's my radius, right? And I would take that answer, but a better answer would be a 6x pi. That's a much better answer, okay? All right. How am I doing? Pretty good? Good review? You guys will be able to do really well on this on Monday, right? Okay, number 7. So let's go negative 2, 2. There's A. 2, 1, 2, 3, 4. There's B, right? I'm going to draw the line segment in. There's a little ruler. Midpoint. All right. I really like to do things by counting. I mean, this is a geometry class, so everything is visual. You could use the formula, but for me, it's just a lot easier to just say, okay, well, midpoint's halfway. So if I counted 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, midpoint would be half the journey, right? Half the journey. Instead of going 6, 4, midpoint's going to be 1, 2, 3, 1, 2, and there's the midpoint right there. So my midpoint is at the coordinate 0, negative 1. If you want to use the formulas, Jaden, turn around and point to the door, right above the door. There it is. You guys see it? There's the midpoint formula. Every formula is in here, you guys. The only formula that's not in here is a quadratic formula. I used to have it, but it fell apart. Okay, length. Okay, now, again, Emma, turn around and point to the board. That way. There's the distance formula, right? Or length. Same thing. So that formula's up here too, right? However, I prefer to use a right triangle, okay? I think it's much easier to take a look at a right triangle. A squared plus B squared. Remember, A squared plus B squared equals C squared, or leg squared plus leg squared equal hypotenuse squared. So 6 and 4, so I have a 6 squared plus a 4 squared equals a C squared, right? I'm just going to find the length of AB using Pythagoras' theorem. I call that C. 36 plus 16 equals C squared, right? What's that, 52? 52 equals C squared. How am I doing, okay? So C, you got to take the square root of it, square root of 52. That answer is great. I would take the square root of 52. That is an answer. That's an exact answer. Or I would say, okay, if you want to just find out what the square root of 52 is, about 7.2, okay? Or approximately equal to 7.2. Either answer, okay? Either answer. Okay. Now, number 10. Triangle ABC. Let's graph 1, 2, 3, 4, 5. 1, 2, 3. There's A. B is at 3. Negative 3. 1, 2, 3. There's B. C is at negative 1, negative 2, and there's C. So let me draw my triangle. We're going to do a translation, which you guys probably already know how to do. All right. This little rule that I highlighted tells me where to move the triangle. I'm going to move the triangle. Every x value is going to go back 3, and every y value is going to go up 1. So really, I'm going to take the entire triangle back 3, up 1. That's what this says. X values go back 3, and y values go up 1. So let's do that. Let's go ahead and take it. Let me get a different color pen because I want to be able to show this in a different color pen. Orange it is. So I'm just going to take every important point. I'm going to go back 3, 1, 2, 3, and up 1. Okay. And we're going to call that C prime. take B and go 1, 2, 3, and up 1. We'll call that B prime. We're going to take point A, back 3, 1, 2, 3, and up 1. We'll call that A prime. Okay, now I'm just going to draw in my new triangle. Okay, so this is my translated triangle. Translation is another way to say a glide. Okay, a translation is a glide. Okay, so the new coordinates. Well, let's see. 2 ways to get it. The one we just counted. That's easy, right? We just count what's the coordinates of A, B, and C. The others you can just simply take and subtract 3, add 1 to each coordinate. Does that make sense? I'll take A. I know A prime has got to be, let's see, if I subtract 3, I'd have it at a 2, and add 1, 4. Okay, let's double check. 2, 4, yeah, there it is. Hey, it works. What do you know? The math works. Math always works. B prime, let's see, if I subtract 3, I'd have it at 0, and add 1, I'd have it at -2. Hey, what do you know? It's exactly where it's at, right? And C prime, let's see, if I subtract 3, I'd have it at -4, and add 1, I have it at -1. What do you know? That's exactly where it's at, okay? Those are the new coordinates, okay? So we just did what we call a translation. Translation is a glide, okay? And what we did with this glide is it didn't change the shape at all, did it? Didn't change the orientation. It's just moving it back and forth, and that's called a glide or a translation. Okay, now that's a lot of homework, isn't it? Let's shorten this. Let's just do the odds instead. Let's go 1 to 23 odd, which is only really about 12 problems. And don't forget to draw the picture, show the